Hi, and welcome to Intro to Trig Day 4. Today we are going to be talking about special right triangles, and unlike yesterday, we will not be needing the calculator for this portion of the notes. When you are asked to find the exact value, that means we use a 30, 60, 90 degree triangle or a 45, 45, 90 degree triangle and our unit circle. So first here I have our 30, 60, 90 triangle. And our 30, 60, 90 triangle is in the ratio of 1 to 2 to radical 3. The 30, is 1 is always across from the 30, the across from the 60 is always the radical 3, and the hypotenuse is always 2. We talked about that on the first day of these notes, and I showed you how that relationship worked. In your 45, 45, 90 triangle, this is an isosceles triangle, meaning these two sides have to be congruent. So this is a 1, this is a 1, and my hypotenuse is a radical 2 this time. And if you don't believe me, all you need to do is use the Pythagorean theorem and leave out one of the sides, you'll get the third side. Here we have our unit circle. Remember, this is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. And this is the point 0, negative 1. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then this brings us back to 360 degrees. Okay, remember everything is always in the form of xy, and that is cosine theta, sine theta, and tangent theta is y over x, or, because I'm getting too close to the edge there, it's not taking it, tan theta. Okay, like I was saying, tangent's equal to sine theta over cosine theta. Alright, so now using this information, we're going to fill in this chart here. The sign of 0, we know that 0 is on the unit circle. That's the only place it shows up is on the unit circle. So on the unit circle, the y value at 0 degrees is 0. The x value at 0 degrees is 1. And the tangent is y over x, so 0 divided by 1, which is 0. We've done that before. 90 degrees is also on our unit circle, and it's also on our triangles. But when you have a right angle in the triangle, you don't ever use that angle. We always use the other angles because the right angle is always across from the hypotenuse. So for the 90-degree angle, we go back to the unit circle. The y value, so the sine of 90, the y value at 90 is 1. The x value at 90 is 0, and the tangent is y over x, so 1 divided by 0, which is undefined. My 30-degree angle is found in my 30, 60, 90 triangle. So I look at my 30-degree angle, and I find the sine of that. The sine of 30 is opposite over hypotenuse, so it is 1 over 2, or 1/2. The cosine of 30 would be adjacent over hypotenuse, so that is radical 3 over 2. And the tangent of 30 is opposite over adjacent, so I'd get 1 over radical 3, but we can't leave it like that. We have to rationalize, so times radical 3 over radical 3, so we get radical 3 over 3. For our 45, 45, 90 triangle, the sine is opposite over hypotenuse, so I'd get 1 over radical 2. We have the same issue here, so we get radical 2 over 2. the cosine of 45, and when you're in the 45, 45, 90 triangle, it doesn't matter which angle you choose because they're both 45 degrees and you're going to get the same answer both ways. The cosine is adjacent over hypotenuse, which is 1 over radical 2, which we already discovered is radical 2 over 2. And the tangent is opposite over adjacent, so it's 1 over 1, so it's 1. 60 degrees is found in the 30, 60, 90 triangle, so we go back to that triangle, and I look at the triangle, and I find the sine is opposite over hypotenuse, so it's radical 3 over 2. And the cosine of 60 is adjacent over hypotenuse, so it is 1 over 2. And the tangent of 60 is opposite over adjacent, so it's radical 3 over 1, so it's just radical 3. These are all the values that we can find using our right triangle and our unit circle. So we did not get rid of SOHCAHTOA. And all this stuff we just did here, you must memorize. Okay? When I say must memorize, that includes our unit circle, our right triangle, and our charts here. Everything I have here that I'm trying to cover up is what we must memorize here. Okay? So, when I say memorize, I mean know your unit circle. There's really nothing to memorize on the unit circle because you know all the degree angles and you know all the coordinates. Just know how to use it, the y and the x and what they stand for, and to be able to find tangent. You have to memorize the sides of the 30, 60, 90 and the 45, 45, 90 and how to use SOHCAHTOA on it. So that's really all I'm asking you to do is memorize the sides of the 30, 60, 90 and the 45, 45, 90 triangle. Know how to label your unit circle and know how to use x and y to find sine, cosine, and tangent. Okay? Looks a little intimidating, but I think you can do it. So find the exact value, the sine of 45 degrees plus the cosine of 45 degrees. Once I have my chart filled in, I can go right to my chart and use my values. The sine of 45 is radical 2 over 2 plus the cosine of 45 is also radical 2 over 2. So I need to add them together. They are like terms in the denominator and they have like terms in the numerator. So I have 2 radical 2's over 2. My 2's cancel out, so my answer is just radical 2. Again, it says exact value here, so we cannot just plug that into the calculator and get our answer. The sine of 45 degrees squared plus the cosine of 60. Well, the sine of 45, if we look in our chart, is radical 2 over 2, and we're going to square that, plus the cosine of 60. Well, the cosine of 60 is 1/2. If I square root 2 over 2, radical 2 times radical 2 is 2. 2 times 2 is 4, plus 1/2. Have to find a common denominator here. And if you look at it, 2/4 is a half. So 1/2 plus 1/2 is 1. The tangent of 180 plus the sine of 60 times the cosine of 30. Well, the tangent of 180 is not in my chart, but if I go back up to my unit circle up here, tangent is y over x, so I have 0 over -1. So I'm looking at the 180 degrees. That would give me 0. I'll be honest with you, this when you're doing tangent, you're never going to use an undefined in the middle of a problem. So it's 0 plus the sine of 60. The sine of 60 in my chart is radical 3 over 2 times the cosine of 30, looking in my chart, is radical 3 over 2. So radical 3 times radical 3 is 3. 2 times 2 is 4. So my answer is 3/4 because I would be adding 0 to it. For number 4, the tangent of theta is equal to radical 3 over 3. Find theta. Well, go back in your chart. Where in the tangent line do you see radical 3 over 3? When I look I see at 30 degrees, I see that the tangent of theta is equal to radical 3 over 3. So that means that theta is equal to 30 degrees. So that's finding an exact angle and how you use that. And the back side is just a review of what we did last night. So if the tangent of A is equal to 1.3450, find the acute angle A to the nearest 10 minutes and B to the nearest minute. So if I put this into the calculator, I would do second tan and then type in my number, and I would get angle A is equal to 53.3694031. I need to hit my degrees, minutes, second button that we did yesterday, that DMS. And angle A is then 53 degrees, 22 minutes, and 9 seconds. So to the nearest 10 minutes, I need to look here. I have 22 minutes. The question you have to ask yourself is 22 closer to 20 or is it closer to 30? It's closer to 20, so therefore we'd have 53 degrees and 20 minutes. To the nearest minute, we look to the seconds. Is this more than 30 or less than 30? Well, it's less than 30, so we don't have to round up. We just leave it where it is. So it's 53 degrees, 22 minutes. If the cosine of A is equal to 0.8247, find the acute angle A. Again, on the calculator, I would do second cosine. And when I did that, I would get angle A equals 34.441912229. And I turn it into degrees, minutes, seconds. So angle A is 34 degrees, 26 minutes, 30 seconds. So nearest 10 minutes is 26 closer to 20 or 30? It's closer to 30, so it would be 34 degrees, 30 minutes. And I'm at 30 seconds, so I'm going to need to round up to the next minute. So it would be 34 degrees, 27 minutes. For number 3, round to 4 decimal places. So we type this into the calculator, tangent of 3 degrees, 47 minutes, and I would get 0.0661. And to type this one in, the 46 degrees, 8 minutes, you'd actually have to type it in as 46 degrees, 08 minutes. On some of the calculators, on other ones it's not, but it's good practice to do it this way. And when you type that into the calculator, you would end up with 0.6930 to the 4 decimal places. All right, and that's it for today.